Lesson 6-2, page 290. Number 1, the dimensions for a rectangular prism are x plus 5 for the length and x plus 1 for the width and x for the height. What is the volume of the prism? All right. In the last lesson, we did addition and subtraction. Okay, and with the addition and subtraction, you had to combine like terms. Multiplication, you can multiply anything. All right, so volume of x is the length times the width times the height. And up here it said, so the volume of x is going to be the length, which is x plus 5, times the width, which is x plus 1, times x. Okay, so let's try that. We got x times x, that's x times x is x squared, plus x times 1 is 1x. Then we have 5 times x, 5x, and then 5 times 1 is plus 5. And then that's going to be times x. Well, we got some like terms in here. We can add those together. So that's going to give us x squared plus 6x plus 5. That's going to be times x. X squared times x is x cubed. 6x times x is plus 6x. And then 5 times x is 6x squared. And then 5 times x is 5x. Okay? There's a couple different ways that we can do this, and I'll show you in those lessons. But I want to show you something here real quick. This right here, I'm going to graph that. Watch this. We're going to go over here and on new document. No, we're going to go to graph, and we've got x plus 5 close parentheses times, and then we have x plus 1 close parentheses, and then times x. Now, when you're putting this in the calculator, you got to make sure you put times between them. And then you press enter. All right, so that's what it looks like. Now we're going to press tab, and we're going to look at what we x cubed plus 6x squared. X cubed plus 6x squared plus 5x. Now, if we've done this, our multiplication correctly, this new one will lay right on top, and it did, it laid right on top. So that's a way you can check and see if you've done your multiplication properly. Now, if you have a multiple choice test, you can, let's see here, we'll use 3. You got to make sure that you use a prime number, and we're putting 3 in for x. So we're going to go open parentheses, x plus 5, close parentheses, times, and then x plus 1, x plus 1, close parentheses, times, and then just x, enter, and that gives you 96, and then we'll check what our other x cubed, I think it was, x cubed plus 6x squared. Make sure that you plus 6x squared plus, what was it, 5x? 5x. And, okay, that's another way. And like I said, on a multiple choice test, you can put the original in and then the A, B, C, and D and check and see which one is right. All right. So number 2. Perform the following polynomial multiplications. I'm going to show you 2 ways to do it. One is the distributive method, and that's where you take like 3x times x squared, 3x times x squared, and that would be 3 times 2 is 6, x cubed, and then 3x. 3x times 3x, and that would be plus 9x squared. And then 3x times negative 1 would be minus 3x. And that's the first one. And then we're going to do the bottom one. Or the negative 2 times negative 2x squared would be minus 4x squared. Then negative 2 times 3x would be minus 6x. And then, last but not least, negative 2 times negative 1 would be plus 2. And we're going to go and see 6x cubed, no other x cubed, so we got 6x cubed. And then we've got 9x squared and minus 4x squared, so that's going to be plus 5x squared. Next, we have minus 3x minus 6x. It's going to be minus 9x. And then all that's left is plus 2. Plus 2. Now, that's the distributive method. The next method is called the box method. And let's see here, let's make us a box. Make us a box over here. And then we'll put some, we're going to want something little, we're going to want a solid line. And then we've got 3. You might call them a Punnett square in science class. And then what do we got? We have 3x and minus 2. And then we have 2x squared, 3x, and negative 1. 3x times 2x squared would be 6x cubed. 3x times 3x would be 9x squared. 3x negative 1 is negative 3x. Negative 2 times, that would be negative 4x squared. Negative 2 times, that's minus 6x. And negative 2 times is positive 2. And you'll notice you got 6x cubed. And then these two here, not always, but a lot of times those twos there will combine, and that makes plus 5x squared. Again, these two combine as minus 9x, and then you're left with positive 2. And you'll notice both of those answers are the same. So that's number 2. Number 3. The distributive method on this one is kind of complicated, so we'll just make us a box here. And we got x cubed, 3x squared, 1, 3x squared, 6x, and negative 2. X cubed, 3x squared, that's 3x, and then 3 plus 2 is 5. X cubed times 6x, that's going to be 6x, and 3 plus 1 is 4. X cubed times negative 2 is negative 2x cubed. 3x squared times 3x squared, 3 times 3 is 9x, and 2 plus 2 is 4. 3x squared times 6x, 3 times 6 is 18x, and then 2 plus 1 is 3. 3x squared times negative 2, that's going to be negative 6x squared. That's going to be 3x squared. That's going to be 6x, and that's going to be negative 2. Now let's take a look. We've got 3x to the 5th. No other those. And then we've got these two here. They go together. X to the 4th and x to the 4th. So we're going to have plus 15x to the 4th. And then we've got x to the 3rd. And these two here are x to the 3rd, and that's the only ones. So 18 minus 2 would be plus 16 x cubed. And we have 3x squared and negative 6x squared. So those two there, 3 minus 6 would be minus 3x squared. And we have just 6x plus 6x and minus 2. And just to go back, if the degree of this is 5, because you got a 5 right here, and the leading coefficient is 3. All right, number 4. Here's another one where we have a 3 and a 3. This time I'm going to show you using the distributive method. You have x squared times 3x squared. That's going to be 3x to the 4th. Then you're going to have x squared times 9x. That's going to give you plus 9x to the 3rd. Remember, this is 9x to the 1st. You have x squared times 5. That's going to be plus 5x squared. We have 9x times 3x squared. That's going to be plus 27. 3 times 9 is 27. X to the 3rd. 9x times 9x. That's going to be plus 9 times 9 is 81. X and 1 plus 1 is 2. So 81x squared. And then we have 9x times 5. That's going to be plus 45x. And then now let's do the third term. 7 times 3x squared is going to be plus 21x squared. 7 times 9x is going to be plus 63x. And then 7 times 5 is going to be plus 35. All right, now here's where it gets a little tricky. We got x to the 4th here, right? Any more x to the 4th? No. So we have 3x to the 4th. We have 9x cubed. We have 27x cubed. Any other x cubed? Nope. 9 and 27 is 36x cubed. Now we have 5x squared. We have 81x squared. We have 21x squared. Okay, so we got 5 and 81 and 21. 5 plus 81 plus 21, 107. So that's going to be plus 107x squared. All of those are taken care of. What do we got here? 45x and 63x. 108 plus 108x and then plus 35. Not too shabby. Not too shabby at all. I think I wanted to do 5 first. We're going to do 5 on the form. And then, let's see here. I'm going to do 6 for you. And again, let's see here. I'm going to show you again with the box method. We got x cubed x squared, and 1, x squared, negative x, negative 5. X cubed times x squared is x, and then 3 plus 2 is 5. X cubed times negative x is negative x, and 3 plus 1 is 4. And this is negative 5x cubed. X squared times x squared is x. 2 plus 2 is 4. X squared times negative x. 2 plus 1 is 3. X squared times negative 5 is negative 5x squared. 1 times x squared is x squared. Negative x and negative 5. All right, so let's see what we got. We got x to the 5th. And looks like we got 2x to the 4th. Any other x to the 4th? Nope. So, ooh, and look, x minus x is 0, so those cancel out. And let's try x cubed. We got 2x cubed here and here. Negative 1 minus 5 is minus 6x cubed. We have an x squared and a minus 5x squared. That's going to give you minus 4. 1 minus 5 is negative 4x squared. And then we have a minus x and a minus 5. And that takes care of that. Not too shabby. We'll let y'all do number 7, and you can put that on the form. Number 8, we're going to skip 8. We're going to skip 9. And I like to do those in class, not so much here. Let's try a word problem. A biologist has found that the number of branches on a certain rare tree can be modeled by the polynomial branch of y is 4y squared plus y, where y is the number of years after the tree reaches a height of 6 feet. The number of leaves on each branch can be modeled by the leaves of y equals 2y to the third plus 3y squared plus y. Write a polynomial describing the total number of leaves on the tree. Well, let's see. The total leaves on the tree would be, well, the branch y times the leaves of y. Okay. So that's going to be 4y squared plus y times 2y, I don't know why I wrote an x, probably because I'm just used to it, 2y cubed plus 3y squared plus y. Okay, and just, well, we'll do it like this. We've got 4y times 2y to the third, that's going to be 8y to the fifth. And then we got 4y times 3y squared, that's going to be plus 4 times 3 is 12, y to the fourth. And let's see, now we have 4y squared times y, that's going to be plus 4y to the third. Now let's try y times 2y cubed would be plus 2y to the fourth. Y times 3y squared, that's going to be plus 3y to the third. And then y times y would be plus y. 1 plus 1 is 2. So what do we got here? What can we combine? It looks like we can combine this and this. It also looks like we can combine this and this. Anything else? Nope. So here's our answer. 8y to the fifth, and then 12 and 2 is 14 plus 14y to the fourth, and 3 and 4 are 7y to the third, and plus y squared. So the total leaves on the tree can be modeled by this function here. 8y to the fifth plus 14y to the fourth plus 7y to the third plus y squared. An object thrown in the air has a velocity after t seconds that can be described by v of t equals negative 9.8 t plus 24 and a height. The object has mass m equals 2 grams. The kinetic energy of the object is given by k equals 1/2 mv squared, and the potential energy by u equals 9.8 mh. Find an expression for the total kinetic and potential energy k plus u as a function of time. That looks like a real good problem for y'all. Number 11. See what y'all can do with that. We're going to skip verifying these polynomials. That's just more practice of multiplying. But here is a way you might use some of this stuff. Can you square 43 in your head? Probably not. But what you can do, okay, 43, let me ask you, is that not the same as 40 plus 3, right? And this is squared, so that would be the same thing. All right, and let's see, which one am I doing? I'm doing this one right here. So x squared, 40 times 40 is 1600, 2xy. So let's see here, 40 times 3 is 120, times 2 is plus 240. And then y squared, 3 times 3, that's plus 9. So I'm getting 1849 for your answer. All right, well, let's try that in the calculator. I know it's a lot faster in the calculator, 43 squared. But if you are stuck on a beach in Aruba without your calculator, you could do it real quick in the sand. 1849, there we go. What about, well, you can do 17. It's just like 16. What about 89? 89 squared. How would we do that? How would we do that? That might be this one right here, right? Because I would do like 90 minus 1, and that would be 90 minus 1, right? Well, 9 squared is 81, and you got 2 zeros, 8100. And then that would be, well, negative 1 times 90 is negative 90. 2 times, that would be minus 180. And then y squared negative 1, that's going to be plus 1. Okay, so I'm looking at 721. I wonder if that worked out. Let's see. 89 squared. 7921. 792. Oh, golly. 7921. 7921. Because 8100 minus 100 is 8,000. Or, yeah, 8,000, not 800. Minus 80 would be 7920. Yep, there you go. All right. What about 19? Since I screwed up number 10 or number 18, I'm going to say 45 plus 2. And then 45. I can't do that. What about 50 minus 3 times 50 minus 3? That I can do, because 5 times 5 is 25, so I got 2,500. And then that's minus 150. That's going to be minus 300. And 3 times 3 is 9, so that's going to be plus 9. So that's 2209. Let's see if we got that. 2209. 47 squared. 2209. Wow. All right. Okay. Folks, that's it for the day. I hope you have a wonderful afternoon and enjoy. And we'll see you when you get back to school.